Hey Prob and Stats, we're going to talk about a continuous random variable today. So this is actually kind of something we've already talked about in chapter 2 when we were talking about z-scores and doing all the calculator commands for normal curves. So that is a continuous random variable. So we're just going to go into details. So a continuous random variable is a variable which takes all the values in an interval. An interval of numbers. So there's infinitely many values on a continuous scale with no gaps or interruptions. Okay. So the probability distribution is described by a density curve. Okay, and continuous random variables, I want you to note that, so little stars up there, that greater than or equal to or greater than, it doesn't matter. We can't tell the difference in continuous, okay? Because we start talking about calculating area, and there's no difference here. When we are talking about discrete problems and we're looking at a table, we can tell if we're including a value or not. But here, it doesn't quite work that way. So the probability model of a continuous random variable assigns probabilities to intervals of outcomes rather than to individual outcomes. In fact, all continuous probability distributions assign a probability of 0 to every individual outcome. Okay, because the reason is we are talking about area. When we talk about area under a curve. And so there's like no area to just a line. We can't just have one value. We have to go from here to somewhere else, and then we can calculate that area. But we can't just have the area of a line. There's no area. So the probability of an event is the area under the curve, okay, and again we're talking about area, and above the interval of values of x. Okay. So a couple examples of continuous random variables. We kind of saw some examples where we had to label some already. So things where measurement happens, so height, weight, time required to run a mile, the temperature in a room, etc. So things that require measurement. Okay, so our first example, let x be a randomly generated number between 0 and 1. The distribution of many trials is represented by a density curve that is called uniform. Okay, so uniform means that it goes straight across. So we're talking about numbers between 0 and 1, and they just go straight across. So uniform, my lines are a little bit off. Basically, it just looks like a rectangle. Okay, and when we know it's a density curve, the area under the curve is 1. Okay, so when we talk about area, this is the length, is 1, so the height must also be 1, so that 1 times 1 equals 1. Okay. Okay, so then it asks us to find just the area from 0.3 to 0.7. Okay, so I'm just going to draw these again just so we can sketch them for each problem. Okay, so 0.3 to 0.7. I know the height is 1. What's this distance from 0.3 to 0.7? 0.4. So 0.4 times the height of 1. So the probability that our x is between 0.3 and 0.7 is 0.4 times 1, so just 0.4. Okay. So if we look at 0 to 1, 0.5, we have our density curve. So we want less than or equal to 0.5. So what do we think about that? That area is just going to be 0.5. Okay, notice this symbol was less than or equal to. Would that have changed at all if we had just used a less than? It would not. So the same, this would be the same as if we did probability x is just less than 0.5, okay? Because there's no area at 0.5. You can't just drop down to 0.49. Don't do that, okay? So it's just 0.5. Okay, 0 to 1, and now, oops, sorry, that's not very straight. We're going from 0.8 greater than, so what's that distance from 0.8 to 0.1? Yeah, it's 0.2, so this, let's write up here, will equal 0.2. Okay, oops. So here we're going from 0 to 1. We have just two different situations that we're going from 0.5 and below. Okay, or we go to 0.8 and we're going to go greater than. So that area will be 0.5, or we're going to plus, the top would be 0.2, so that's 0.7. Okay, so we're talking about normal curves. What do we need to find the area under a normal curve? I kind of gave you a little hint on the intro. We're going back to z-scores. Okay. So what's the formula for a z-score? Do you remember? Hopefully. It'd be the value minus the mean divided by the standard deviation. Okay, so I wrote it in symbols. And then the calculator commands, there are two of them. Do you remember? Remember what they are? They're going to be normal CDF. Okay, and you have to put boundaries, two values in there. So sometimes we're going in between two values. Sometimes we're going to positive infinity, negative infinity, whatever you need. The other one, okay, so this gives you area or the percent under the curve. Okay. Inverse norm, you put in the area and you get out a z-score. Okay, so z-scores go into normal CDF and you get out the area. Over here, let me just label for the z-score formula, the mu is the mean and the sigma is the standard deviation. And they usually give you like the shorthand notation, normal, parentheses, the mean, comma, the standard deviation. Okay, so if you see that in a problem, that's what they're telling you. All right, so example 8, we want to sketch a curve and determine the probability for the following normal distributions with a mean of 65 and a standard deviation of 4.5. Okay, so we know it's normal, we've got our mean, we've got our standard deviation. Okay, so we want to sketch a curve and then calculate these things. So for our curve, we're centered at 65. 70 is up here. We want to go less than 70. Okay. First step, we know we'll find a z-score. So our z-score, the value would be 70 minus the mean, so 65, divided by the standard deviation. So if you don't already have your calculator, go ahead and grab your calculator. I want you to go ahead and calculate that. Okay, so you should get 1.11. So that's the z-score. That tells us how far above the mean it is. The next thing we want to do is normal CDF. Do you remember we're going from over here negative infinity, so we are negative 1 e to the 99, comma 1.11. Okay, so the normal CDF, if you don't remember, you're going to hit second vars, which vars is right by your arrows, and then go down just one to normal CDF, and enter negative infinity, the negative 1 e to the 99, 1.11. Okay, so go ahead and help each other out if you can't find it. You go to second vars, which is where distribution is, normal CDF, and enter that in your calculator. So you should get 0.867. 0.86 is fine. Okay, so let's do a couple more. The next one, we're centered at 65. We're going to 58. And we want greater than. It goes this way. So again, we're finding z-score for 58 minus 65, and then divide by our standard deviation of 4.5. So go ahead and find that z-score. Okay, so you should get negative 1.55 repeating, so 1.56. Remember, with your z-scores, you have to use at least 2 decimal places. It's perfectly fine if you want to use 3, but you need at least 2. Okay. Then we're going to do normal CDF. And this one, we're starting at our z-score, negative 1.56, and going up to positive infinity. So 1e to the 99. Okay, so when you calculate that, you should get something close to 0.94, depending on how many decimal places you used. Okay, so that's the area under the curve. So notice that we shaded in most of the curve, so it should be 94%. Okay, one more we're going to do here. We're centered at 65. We're going all the way down to 52 and up to 70. We're going to do in between these two values. So 70 was in part A. We already have that z-score. I just need a z-score now for 52. So we're going to do 52 minus 65 and divide by 4.5. Okay, so find that z-score. Okay, so this you should get a negative z-score. It's below 65, so negative 2.8889. Okay. All right, so our normal CDF, we're going in between two z-scores. So we're going to go from negative 2.89 up to 70 had a z-score back in part A of 1.11. Okay, so we're going to do normal CDF in between those two. So if you use more decimal places, your numbers can be slightly different, but it should be close to like 0.86, like 4? 0.864, 0.865, something like that, okay? Okay, so that's a little review. We've seen all of those solving problems before, so I'm glad we're kind of doing this right before the final, because this material will be on the final as well. Okay, so we're just going to go through a couple examples with like word problems. And then, so here in this last example, we use normal CDF a couple of times. The next one, we're going to use the other calculator command. Okay, so let the random variable X represent the profit made on a randomly selected day at the Oak Ridge High School student store. Assume X is normal with a mean of 100 and the standard deviation of $15. There's a 60% probability that on a randomly selected day, the store will make less than how much? Okay, so we know that it's normal. Okay, a few things, a mean of 100, standard deviation of 15, key thing. And then we know there's a 60% probability. Okay, so let's start off with a curve. We know it's normal, so we can draw a normal curve. We're centered at 100. So what's the other piece of information that we know? It's the 60%. We don't have another value. We're going to use the 60%. So 60% probability that on a randomly selected day, the store will make less than how much? So we want to find the number where 60% is below that. They're making less than, so less than some value. We're going to put whatever this number is, and then this would be 60%. So we want that value where 60% is less than it. So what is this? We don't know. Do you remember how to find this? Okay, so we're not going to use normal CDF. We're going to use the other command, which is inverse norm. So we're going to do inverse norm of 0.6. Okay, and what that does is it's going to put out our z-score. So inverse norm is right by normal CDF. So you go to second distribution, down to inverse norm, and we're going to do 0.6. Okay, so that comes out with a z-score of 2.253. So make sure you note that that's still a z-score. That's not our answer. Okay, so we're going to plug that back into our z-score formula. So this becomes 0.253 equals, we don't know the value, minus the mean of 100, and divide by our standard deviation, which is 15. Okay, so to solve this, you multiply by 15, so 0.253 times 15, and you're going to add 100 to the other side. So go ahead and solve that to find out. So you should get a number that's bigger than 100. We have 60%, so it should be above 100, just so you know. Okay, so we should get 103.8. Okay. Or I guess we're dealing with money, so you could put, well, yeah, it rounds up to 0.80. Okay. So there's a 60% probability that on a randomly selected day, this store will make less than $103.80. Okay, so your answer is 103.80. Okay, one more problem. Example 10. So assume that the length of time x between the charges on an iPod is normally distributed with a mean of 10 hours and a standard deviation of 2 hours. So this is like an old problem because hopefully charges are lasting longer than that now. Okay. So find the probability that an iPod charge will last between 6 and 10 hours. Sketch a curve. Okay, so we know it's normal. We've got our mean of 10, standard deviation of 2. Okay, so our curve, we know we can draw a normal curve because it said it was normal. We're centered at 10, and we want to go between 6 and 10. Okay, so we need z-scores for both of those. So z-score for 6, we're going to subtract our mean of 10 and divide by 2. So hopefully you can do this one in your head. 6 minus 10, negative 4, divided by 2, get negative 2. What's the z-score for 10 if that's our mean? Do we know that? What's the z-score for 10? Well, we can solve it. It'd be 10 minus 10, which is 0. So the z-score for the mean is 0. So those are z-scores. We want to know the probability or that area. So now we're going to use normal CDF. We're going to go from negative 2 to 0. Okay, so plug that in your calculator. Second distribution, normal CDF, so the second one down. Negative 2 to 0. So this should be close to 50%, but it should be a little bit less because we didn't include that whole tail on that left side. So it should be a little less than 50%. And so you should get 0.477. Okay. So the probability is 0.477. Okay, so that's your answer. All right, let's just do part B. The probability is approximately 0.1 that a randomly selected iPod's charge will last at least how many hours? Okay, so let's sketch this out. What is this question asking? All right, so we're still centered at 10. That's our mean. Probability, so we know the answer, 10%. Okay, so we got to draw 10% on the curve that the charge will last at least how many hours? So 10% lasting at least is greater than. So we want this little tail over here where this is going to be 10%. Okay, we want to know what's this value where 10% of the time it lasts at least that long. Okay, so if you remember, inverse norm only does the percent to the left. So if we want the top 10%, what's the percent that's to the left of this value? Yeah, it's going to be 0.9. Okay, so let's find inverse norm 0.9. That again is going to give us our z-score. So 1.28. And we plug that into our z-score formula. So 1.28 equals, we don't know the value, minus the mean of 10 divided by the standard deviation of 2. So you're going to multiply by 2 and then add 10 to the other side, so it should be bigger than 10. Okay, we're above this mean over here. So go ahead and solve that. Okay, so when you solve that, you should get 12.56. So how long? That's going to be in hours. Okay, so that's our missing value. So your worksheet tonight is going to talk about these normal curves as well as a uniform distribution, which is what we talked about at the very beginning, where you had just a rectangle, okay, and you're finding that area. It's also going to include some problems that were that we talked about earlier in this chapter that were discrete problems, so before break. So you have a little review of that plus the normal problems. Okay, so that's your homework, worksheet number 4, and I'll talk to you guys later. Bye.